welcome to Live Happy, Eat Dirty, a podcast full of quick and dirty health and diet ideas for real people, hosted by me, Kate Harrison. Keep listening for the latest weird and wonderful ideas and interviews from the worlds of psychology, nutrition and more. If you loathe detoxes and clean eating, but love evidence-based tips and eating well, you're in the right place. Because you can be slim without giving up cheese, you can be fit without ever trying a triathlon, and you can enjoy your life without having to be a saint. Ditch the guilt. A happy, dirty life is so much more fun. Here's today's show. Hello and welcome to a special Live Happy, Eat Dirty podcast focused on the bugs in our guts. As part of my research for the Dirty Diet book, I was lucky enough to talk to Dr Lesley Hoyles from Imperial College in London about the gut microbiome, the collection of bacteria and other microorganisms that coexist with us in our bodies and influence so many aspects of our health. In this interview, talking to Lesley, we cover so much, from weight loss to childbirth, and even the one kind of transplant you don't want to be discussing over breakfast. Apologies that the sound is a little bit weird in places, but Lesley is such an expert. I hope you'll agree this is definitely worth a listen. So joining us today is Dr Lesley Hoyles. Just a little introduction. Lesley is a microbiologist and computational biologist based at Imperial College in London. She trained at the University of Reading and also in Ireland before taking up her position as a research fellow, specialising in using a mixture of lab work and computing to look at the effects of diet on the microbes that live inside us. And she also runs the Bugs in Your Guts website and Twitter account. Welcome, Lesley.
Hello, nice to speak to you.
And you too. Let's start at the very beginning. What exactly is a microbiome?
Right, that's really a two-part answer. The first bit involves the microbiota, which is basically all of the bacteria and viruses and fungi and various other microscopic organisms that live in your gastrointestinal tract. The microbiome is basically everything that can affect the composition of the microbiota. So that's the amount of water and nutrients available to the bugs in your gut, the temperature, any drugs you're taking, your physical activity, your general health and well-being. So it's very much linked in with what we do and what we eat, and how that affects bugs and how they interact with us. So it's very much a symbiotic relationship between us and all the organisms.
It's not just your gut that has its microbiome, is it?
No, every part of your body got its own microbiome. So the vaginal microbiome for women is very important in keeping for vaginal health. As soon as there's a change or an imbalance in the microbes, you can get bacterial vaginosis, thrush, that kind of thing. So it's very important that the balance is kept with the microbes, and we're beginning to understand the mechanisms and how we can modulate things and keep us healthy.
You say that we're just beginning to understand this. This feels like a really new branch of science.
I became aware of the area in about 1997. I worked at the Institute of Food Research, but at that time most of the work was funded by food companies because there was a big interest in probiotics and prebiotics. So probiotics are the bacteria you find in things like Yakult, and prebiotics are sugars that get to your large intestine intact, and only the bugs in your guts can break them down. So there was a big push for companies who were working in that area to do a lot of research. It wasn't really until Jeff Gordon published his sort of seminal paper showing a difference between the microbiota in healthy and obese individuals that the whole thing exploded, and that sort of coincided with sequencing becoming a lot cheaper. So big data analyses, technology becoming cheaper and affordable to be used in a wide range of labs has led to the field really progressing a lot in the last 10 years, 10, 15 years.
Because we've always had these microbiomes and the microbes living with us and alongside us, but we haven't really been able to find out what's going on until that sequencing became available.
The sequencing was there, but it was incredibly expensive. It wasn't widely available. There was only a few labs that could afford to run it. But it's got to the stage now where for 20 or 30 pounds, you can quite easily sequence all of the bacteria in your gut and have a good idea of the composition. And we've got tools that allow us to look at how they affect our immune system, how the chemicals they produce can turn up in our blood and urine. So we can start linking everything together at a systems level and not just count bugs going up and down. We can put everything together and see how they interlink.
Now, that interlinking that you were talking about, what influence does the state of our microbiota or the microbiome as a whole have on us as human beings?
Oh, the $1,000,000 question. It's undeniable that you have to have certain functions carried out by the microbiota. So, for instance, there's a lot of emphasis put on eating high-fiber diets. Part of the reason for that is because the high fiber is needed to sort of slough off your intestinal cells, to clear them out, to keep your intestinal tract healthy. But also the microbes in your gut produce a chemical called butyrate from fibers, and that basically is the energy source for your intestinal cells. So without that, you're more susceptible to things like colon cancer, possibly inflammatory bowel diseases, and you definitely see a loss of the bacteria responsible for producing butyrate in disease states such as inflammatory bowel disease, and even in obese individuals, you see loss of those organisms. So it has a detrimental effect even at sort of the cellular level for us. That's just one example. There's lots and lots and lots you can go into, but that's probably that's the best study to date.
And how does that balance change? I mean, if we've got a good balance and something goes amiss, what kind of things go amiss?
At the most simplistic level, if you're thinking about a really healthy microbiota, it should have lots of bacteria that really don't like living in oxygen. So by the time your digestive tract, your mouth has got a lot of oxygen in it, so it's an aerobic environment. But as you go down your digestive system, the oxygen is lost and it becomes a lot more anaerobic, so lacking in oxygen. It's part of the reason why poo stinks, basically. It's because we ferment things. You can only ferment things in an absence of oxygen. So all of the bacteria that we really want to be there with lots of functionality that's beneficial to us really don't like oxygen. And what you see when people are unwell, or if they've got conditions like type 2 diabetes, and obesity is the one I keep going back to because that's the one the most work's been doing on, what you find is you see a shift towards organisms that quite like living in oxygen and not oxygen. So they're better adapted and they can outcompete the more obligately anaerobic organisms, the really oxygen sensitive organisms. And those bacteria that are more capable of living in that sort of mixed environment don't have the functionality to produce the beneficial compounds that the really oxygen hating organisms have. That's the most simplistic way of describing it, I think.
When that balance goes the wrong way, that's when we start seeing these disease effects. But how much do we know about whether it's chicken or egg?
That's the $1,000,000 question. And if I knew the answer to that, I'd be a very rich woman. The microbiologist in me says it's what we're doing to the bugs. We're happily living in balance, and then there's sort of a tipping point at which we've changed the microbiota so much and its composition and functionality that then it has a knock-on effect. We've probably got a bit of give, but after a certain point, it starts having a detrimental effect. And that's what we really don't know. At the moment, the microbiome is sort of the hot, sexy topic. Everything's being blamed on the microbiome, but we've probably got as much to answer for as the microbiota itself. So hopefully one day somebody will do the killer experiment to demonstrate it's our fault, but it hasn't happened yet.
By our fault, I mean, we're talking about things that might affect what's going on deep inside. Diet, what else?
Diet, undoubtedly. A more processed diet compared with sort of fruit, veg, more traditional sort of diet. Every medication you take has an effect on your microbiota. There's a lot of interest at the moment in the effect on proton pump inhibitors that people take for acid reflux and the effect they can have on changing the microbiota and possibly making you more predisposed to stomach cancer, other gastrointestinal cancers. Exercise has an effect. There's been quite an intriguing study recently that's shown if you exercise, you can actually maybe restore your microbiota to a more beneficial type, and then as soon as you stop exercising, you seem to lose the benefit to the microbiota. So it's basically everything we do has an influence on the composition of the microbiota. Even the way you're born has an effect on the microbiota and how you're fed as a baby. So yeah, it's very, very susceptible to change and modulation.
I'd love to go into a little bit more detail then, perhaps about that life cycle. So you're talking about birth.
Yeah.
Obviously, there's not much we can do once we've been born. Looking at the whole life cycle, where might the microbiome come in, if you like, both in terms of how it affects us and how what we do affects it.
So if you take birth, for instance, there is a difference. You can detect the difference in the gut microbiota of babies, whether they've been born vaginally or via cesarean section. A colleague of mine who works in the field suggests that the best gift your mother can give you is the first shower she gives you, which is basically giving you your microbiota without going into too much graphic detail. And similarly, there's a big difference between breastfed and formula-fed infants in terms of the composition of the microbiota. And that difference can be detected up until about 7 years of age. You tend to find with breastfed infants, they have a much higher level of bifidobacteria, and that's a lot to do with the human milk oligosaccharides that they're getting from their mother. And those bifidobacteria contribute to the development of the immune system in infants. Once you start weaning kids, you don't really, all become more sort of what we see like in an adult type microbiota. But in the first few months of life, when they're exclusively milk fed, we can very definitely split breast from formula fed babies. There's no doubt about it. So there's quite a lot of interest in maybe making formula milks that are more similar to breast milk. They'll never substitute for breast milk, but making them more similar to breast milk to try and give formula-fed infants the same kind of microbiota that you'd see in a breastfed baby.
And the reason why it's important to have that similar, more kind of natural microbiota is partly to do with the immune system of the child and the...
Yeah, it's partly to do with the immune system and the establishment and maturation of the immune system, because what you find in a lot of work that we've done is in germ-free animals, so they're completely sterile and they're born sterile, and what you see in those is they look nothing like normal animals. Their organs are all malformed. Every barrier, the blood-brain barrier, their gut barrier, everything's leaky. But as soon as you give them bacteria of some description, whether it's one species or whether you inoculate them with feces, like a fecal transplant, their immune system starts to develop, and they will never be normal animals because they're genetically not very good anyway, but they become more normal than they were previously, and they start to develop an proper immune response, and they start to have proper barrier function, and they look a bit healthier. Their weight's affected, their cognitive development's affected, their immune system's affected, their lifespan's affected, everything. So they're not an ideal model for research, but they give us a good idea to how important the microbiota is to our development and health.
So moving on then from birth and whether you were breastfed or not, antibiotics are another huge topic in this area, really, aren't they?
Antibiotics administration is probably one of the things we really don't understand the effect of, because it's not uncommon for infants and even adults to have numerous courses of antibiotics, and how they affect the microbiota long term is of real interest, and how they also affect the dissemination of antibiotic resistant bacteria as well. There's been some nice studies where basically they've looked at the offspring of animals after they've been given antibiotics. So when you take antibiotics, the diversity of your gut microbiota decreases, so it becomes less healthy, if we want to look at it in simplistic terms. You've actually shown that if you compare animals from mothers that haven't had antibiotics to those that have antibiotics, that reduction in diversity is actually transmissible to some degree through generations. So whether that's actually seen in humans hasn't been demonstrated, but it's the fact that it's seen in animal models suggests that it's likely to happen in humans. So it's what's the long-term effect of our exposure to antibiotics? Because it's only since 1930s, really, that humans have been exposed to antibiotics. And while they've been used extensively in farming for fattening animals, we've never really thought about what the consequences are on our systemic health. We've just looked at them in terms of, they've cured an infection, we're better, move on. But they may be having a much more long-term effect on us and our health.
Why would farm animals being fed antibiotics put on weight? And does that give us a clue as to what might be going on with obesity in humans?
I'm not going to make the leap from animals to humans in terms of obesity, but the fact that antibiotics are used in animals to try and help bulk them up, increase meat production, there may well be some links. There's not just antibiotics as far as humans are concerned. You've got a big increase in the availability of processed foods, and some of the compounds that are in, some of the chemicals, that are in those foods, we know will cause certain groups of bacteria to grow a lot more quickly than others, which may affect the microbiota. You've also got the increased use of things like microwaves and other cooking methods that are likely to reduce the nutritional content of the foods we're eating. And if you compare with what people were eating during the Second World War during rationing to what we eat now, and the Second World War ration diet was considered sort of one of the healthiest diets Britain definitely has ever eaten. Look at it to what we eat now, and the fact that we don't really eat seasonally anymore. There's a whole confluence of factors that could be affecting why our microbiota is. Well, it's not that microbiota is changing. We're just more aware that it's something we need to think of. But there's a number of things that could possibly have contributed to the increase in allergies and obesity and type 2 diabetes and all associated diseases.
And immune conditions as well, because obviously that's the other thing, as well as the increase in obesity that we've seen. We're seeing, or we're certainly noticing, more cases of allergies in children and those associated conditions. Is that something that, we talked about the development of the immune system in babies being influenced by their microbiota?
Well, there's the whole argument of the hygiene hypothesis that we're just too clean, and eating a bit of dirt's actually quite good for us. I think Jack Gilbert and colleagues in the States have recently published a book to such effect of basically go out and let your kids eat mud and slugs. And I've certainly noticed, and my mother was a childminder, I've certainly noticed that parents seem to be a bit more precious about kids going out and getting dirty, whereas we didn't think anything about being covered from head to toe in mud for the entire time we were kids. So there's definitely something in there about the fact that kids really aren't exposed to the challenges to their immune system that they would have been at one time. And again, with the confluence of other changes that we've seen, we've got a more sedentary lifestyle. That's a massive factor. It's not just that our diets have changed. We're probably still eating way too many calories for the actual amount of exercise most of us do. So it's a much more complex than trying to pin it on one thing, I think.
And once you've got your microbiome fairly balanced, you're going to see differences then in, never mind the calories that we eat, but how our bodies process them that relate to what's going on down there, aren't you?
Don't tend to see much difference in the microbiota if you eat fat. Because, as I mentioned to you before, my PhD was actually looking at the effect of massive doses of fat getting to your large intestine, and it didn't seem to do much to the composition of the microbiota. And that's actually been replicated in a human study. Definitely the types of carbohydrates you eat will affect the microbiota. The non-digestible carbohydrates that get to your intestine and tract are what we rely on for modulating the microbiota. So the more easily the microbes can break down the substrates they're given, the happier they are, because the less energy they have to use to get the nutrients out and the energy out that they want from the substrate. So yes, definitely, and I think that's where processed food potentially is playing a massive role in the problems we're seeing. That's nobody's fault, because some people just don't have the option of eating anything other than processed foods. I know when I've been to the States, I've been shocked, like essentially food-free zones, where you're lucky if you can buy a bag of Cheetos, and that's probably the most healthy thing that you can find in the shop. So it's understandable why you're seeing obesity epidemics in places where it's just not socially affluent, or they just don't have access to fresh produce that they can have.
That is one of the issues I think that people have, because they will hear contradictory information all the time. Just for example, on the issue of something like sweeteners, so versus sugar, you're going to get into these massive.
Yeah, and aspartame is one of the most well-studied compounds toxicologically. There's so much information on that, and it's probably got way more of a bad press than it should have done. I'm not advocating everyone switches to it by any stretch of the imagination, but it's one of those things, like a little information can go a long way. And a lot of the time with a lot of this work, it's being interpreted too loosely, or if it's potentially lucrative from a financial perspective, that's when all the massive claims come out. And I think that's part of the problem with microbiome research at the moment, is there's so much money that's like billions of dollars potentially that could be made if somebody could crack the code for how do you make people healthy again or restore their microbiota. I despair sometimes with some of the things I've read, and I know Jonathan Eisen on his blog has got a long-running thread that he's got of overselling the microbiome, where he basically takes apart stories which are just completely ludicrous, but which have caught on in the public's imagination. It just gets ridiculous. I recommend you have a look at his website if you want some real horror stories. How the microbiome field can be misinterpreted at times. And to be fair, it's having a knock-on effect with us, because funders are getting to the stage where they're not willing to fund studies because they've been promised so much in the past and so little has been delivered. or they're as sick as we are of the overblown claims. They're moving now more towards, we want mechanistic studies and we want to know how these things are affecting us. We're not interested in counting or sequencing things. We want to know, tell me if I do this, what it does to my body as a consequence of the microbiota, which is more what it should be, really. But for a long time, it's been overblown and oversold.
And how do you go about getting that information, getting something that really works and that makes sense?
Through a lot of time and effort. I think, from my perspective, this one of the big studies I've been involved with has been looking at the effect of non-alcoholic fatty liver disease, and the effect of the microbiota on non-alcoholic fatty liver disease. And from collecting samples to processing the data and writing everything up for publication, it's been about 8 years. So it's not a slow process. And that's a relatively small study as well that we've done. Some of these studies take 10 years before you see anything. And it's only really been in the last sort of 10 years with, as I say, the availability of the cheap sequencing and the fact that people have started realizing all this stuff's linked together. Why aren't we studying it all together? Because what would happen in the past was you'd have 10 people doing 10 different studies, all looking at the same disease or the same feeding regime, but they'd all be looking at different bits and never join the dots together. Whereas now it's much more collaborative and sharing of samples and sharing of data and trying to integrate everything together. The biggest problem we've got at the moment is there's too few people who can actually work with big data. Yes, I'm a microbiologist, but I chose to retrain as a computational biologist so I can do this kind of work. Getting more biologists to retrain to do this kind of work is the kind of thing that we need, so they can interpret the data that they're generating and put it in a proper biological context.
So that it can all be proven and you're not just coming out with things that are might or possible or...
Yeah, so that we can actually say, right, this is what we've shown. What experiment do we need to do to prove this or disprove this, or to give us more questions to ask? So definitely integrative and collaborative research is what you're going to be seeing a lot more of, and it's going to be big collaborative efforts, not just 2 or 3 labs who occasionally publish 1 or 2 papers a year.
Where do you think the most promising work is going on in terms of studies, or that is closest to being able to find real world solutions?
Definitely from the stuff that John Cummings did years ago and people like Glenn Gibson and George McFarlane did. So the sort of beginnings of microbiota research, and people like Willem de Vos in Wageningen. It's unquestionable that a high fiber diet is good for your gut microbiota, or a varied diet high in fruit and vegetables, and just eating within your means rather than gorging or calorie loading. But that again goes back to everything needs to be kept in a balance. Keeping the weight off, doing some exercise, moderate exercise, and just staying healthy is still the best advice you can give anybody, irrespective of what their microbiota is. As far as where the most exciting developments are, I think if we can work out how things like fecal transplants work for Clostridium difficile infections, potentially that work will have translational impact in other areas.
This is what everybody in the media is calling poo transplants, or sometimes poo pills, if you want to.
You can buy crap seals.
Oh, okay. Right. Well, I shan't be Googling for that anytime soon.
No, don't.
This is where we're actually talking about replacing or supplementing what's already in an unhealthy gut with healthier content.
I think this needs to be put in context, because fecal microbial transplants are being used with great success for Clostridium difficile infections, and this is an infection that is predominantly hospital acquired, and it's predominantly in elderly people. They've had massive doses of antibiotics. It's wiped out their microbiota. Clostridium difficile is a spore-forming organism, so it's very good at protecting itself from environmental challenges. And then as soon as that environmental challenge is gone, it's one of the fastest growing organisms as well that we know of. So it can just take over a person's system. And it's very difficult to treat with antibiotics because of the nature of the organism. So what the idea behind fecal transplants was basically putting something back in that could potentially compete with the Clostridium difficile and knock it back down. And what you see in a lot of these patients is they can have recurrent Clostridium difficile infections as well. So if your choice is between having this long-term or dying, or having a rather unpleasant procedure done with a particularly noxious substrate, It was the treatment of last resort, and it worked incredibly well, but we still don't understand how it works. There's some very nice work being done by colleagues over at St Mary's Hospital where it looks like they may have an idea of how it works, but that's just for Clostridium difficile infections. We don't know if it works for obesity. We don't know if it works for Crohn's disease. There's only 3 or 4 institutions in the UK that can actually carry out fecal transplants, and it is very much for Clostridium difficile at the moment. There's also the difficulty with recruiting healthy donors because your microbiota doesn't just include bacteria, it includes viruses as well. So you have to make sure your donors don't have hepatitis or anything else, HIV. I think a colleague in Canada estimated it to find one donor, it costs about $15,000. Once that donor is basically bubble wrapped and kept somewhere pristine so that they don't get an infection, because if they take antibiotics or they have diarrhea or anything like that, they can't be used again. So you have to go back and restart the process. So what some people have suggested is from these healthy donors, you produce these things like capsules or poo pills where you can administer these to people. Or what some people have suggested is maybe creating an artificial community of bacteria, of known bacteria that you can administer to people so you know that it's not going to have any problems with any potentially infectious agents. But again, the success with that has been sort of hit and miss. It's very much still in its infancy. People have advocated using fecal transplants for autism and things like that, and I'd be very, very wary at the moment. We just don't know enough.
But there have been instances where people have either lost or gained weight in an unexpectedly fast way after receiving this for something else.
Yeah, I think there's a couple of reports of people who've had them for Crohn's disease and they've put on weight. There's also several disturbing reports, and this is another thing you don't want to Google, of people who give themselves their own fecal transplants daily and document it. Yes, there is a whole world of YouTube you don't want to investigate.
Yes, it makes the popping of spots seem like very small.
Yeah, acne is nothing.
Perhaps it's a natural thing here to go on to the mental health side of things. There have been reports, and there's certainly been lots of stories talking about the way that the gut can be seen as the second brain, if you like, and the effect it seems to have on our mood and other aspects of our mental health. Can you put that a bit in context? Because it was surprising to me when I first heard it.
Again, that's another area that's really taken off the whole gut-brain axis. There's no doubt that so if you go back to butyrate, the example I gave earlier, there's no doubt that so it's called a short-chain fatty acid, and there's a whole group of them. There's no doubt that they can stimulate the vagus nerve and actually have an effect on communication. If you're healthy, the bugs in your gut shouldn't actually get out and affect you. So it's only the metabolites, so the chemicals the bacteria produce, that affect you. So at any one time, you've got about 200 metabolites in your system that come from your gut microbes, not from you. Now, that's what you're exposed to long term, and that's where the interesting work is going to be. So we know, for instance, from work I've been doing, that certain chemicals produced by gut bacteria can open up the blood-brain barrier, or they can close it. So they can either make it more likely to be affected and affect the brain, or closing it up is actually good for you and stops things getting through. If we go back to obese individuals, what you see in these individuals is they have in their blood, they have very high circulating levels of something called LPS, and this comes from a specific group of bacteria that seems to be enriched in the guts of these individuals. This causes systemic inflammation, but it's also what we use as a positive control for inflammation in brain studies, because we know it induces inflammation. So there's definitely a link in there. And with some of the metabolites, like in individuals with chronic kidney disease, for instance, way before they start presenting to clinics with acute kidney disease, they have cognitive impairments, and that's thought to be caused by accumulation of some of these microbial metabolites in their blood that they just can't clear from their system because they're obviously not well and they've got kidney problems. Again, it's definitely something there, definitely affects our health, but it's too soon to start saying, take this and it will boost your brain power, or don't do this and you'll live longer and you won't get dementia.
A lot of this is about, when we don't know exactly what's going on, aiming for as balanced a life as we can have and as balanced a diet that hopefully will promote a healthy balance within the microbiome, the gut microbiome particularly.
I think that's all you can do. It's The problem at the moment is people are running away with a very small amount of information and making huge leaps from faith or leaps in what they think they know. And I agree with you completely. Be sensible, eat well, exercise moderately, just don't overdo things in general, and it'll serve you better in the long run. Nobody can predict if they're going to get cancer. Nobody can predict if they're going to get type 2 diabetes. Obviously, if you're overweight, there's a very good chance that you will develop type 2 diabetes, but that doesn't mean you will. Similarly, with the microbiota, we can modulate it and try and keep it healthy, but that doesn't mean it's going to make us live longer or becoming susceptible to diseases that just life throws at you. So,
do you do anything within your lifestyle that is aimed at helping your microbiome?
I'd live on a diet of cake and chocolate if I could get away with it, but...
Wouldn't we all?
No, I've always eaten lots of fruit and veg because we always grew our own when I was a kid, and the vast majority of my meals prepared from scratch. I don't like processed food, I never have. I remember turning my nose up at school dinners on the first day at infant school and never eating them again because they were just, this is not my food. So I'm a bit fussy in that respect. That doesn't mean I don't like the odd pie or sausage and chips, but I'm just sensible. Obviously, as I'm getting older, I'm getting more sensible because my brain may think I'm still 18, but my body certainly doesn't. And I still exercise because I enjoy it and it's something I've always done. So, yeah, from my perspective, I try to ignore sometimes what I've learned as I'm tucking into a bag of sweets, but I'm not a virtuous person, so...
And what about the antibiotics and antibacterials? Do you avoid either?
I'm asthmatic, so I can't avoid them. I'm well aware that it's likely the numerous courses of antibiotics I've had during my lifetime are likely to have had an impact on me. But it's just one of those things. It's either that or I'd be dead. So you have to be sensible about these things. It's a bit like not agreeing with vaccinations. I wasn't vaccinated against whooping cough. I had whooping cough. And then my mother suddenly decided, maybe vaccinations against these things are good. So it's only really if it affects you that you have to think about it, really. And I do think there needs to be better public engagement in relation to don't go to the doctors for antibiotics for a cold, because chances are it's caused by a virus and antibiotics will never work on those. Public education in that respect needs to become a lot better. And to be fair, a lot of the societies, like the British Society for Antimicrobial Chemotherapy, they are very good at trying to improve outreach and public engagement, but it still needs a receptive audience. And unfortunately, at the moment, there is this sort of anti-expert mentality around, and it's slightly frustrating.
It does seem to have developed in that way, doesn't it? The antibacterials, do you use antibacterial sprays and hand gels?
No, I don't see the point. Soap does exactly the same job. And I know triclosan, I know that's been, I think in the States it's been removed from products. I don't know what the status of it is in the EU and the UK at the moment, but that definitely has an effect. I think it was just a marketing ploy that tapped into people's sensibilities about, we must be clean. But they pretty much do the same thing as soap in the long run. So I've never seen the point.
And if we're talking about like advertising slogans scream about 99.9% of bacteria removed.
Kill dead.
Chances are quite a lot of those bacteria are beneficial to, or at least not harmful to us in any case.
If the method is used for the purposes it's intended, as in cleaning your toilet, then that's fine. Personal hygiene, yes, we need to be clean, but some people take it to an extreme. And a lot of the products, I just don't see the point of a lot of the products. But that's just me, because I'm pretty cynical about most things. So,
despite the latest bad thing, if you want to think realistically 10, 20 years in the future, how do you think things might look in terms of, will we have a lot more knowledge, or will we just know more about what we don't know?
I think that's true of every age of history and human development. I think in the next 10 to 20 years, it will be entirely possible to go to a doctor's or a nutritionist and get a breakdown of your gut microbiota and the different functions it has that affect your body, and screen your immune function. So screen everything, integrate those data, and maybe give a more personalized dietary guidance. And it will probably become part of a routine health check. But that's going to take significant investment from various research groups, care providers, and buy-in as well from industry and pharma companies. At the moment, the microbiome industries seem to be around, we'll tell you this and you can do this, but there's actually no information available that can unequivocally allow somebody to modulate their microbiota to make it healthier. I'd be lying if I said that it was possible for me to tell you how you could make your microbiome more what I'd say it would, because we don't know what a healthy microbiome is. We've got an idea of what it should be, but we can't say this is this, because everyone's different. Everyone's microbiota is different. But I think, yeah, it will become part of routine checks to go to hospital, to go to doctors as part of an annual checkup. They'll check your microbiota. They'll check all of your immune function and metabolites and try and come up with a whole story. And definitely with the application of machine learning and big data, that's probably going to happen a lot sooner than we think.
I learned it firsthand. So I had my gut microbiota sequenced and everything sent back to me, both when I was eating quite unhealthily, and then I made a really conscious effort for a month to be as healthy as possible. And I also took the VSL3 because I have had IBS myself at times, which is the combination of lots of different probiotics in a form. Waited to get the results back, and eventually after, it takes quite a long time, I got various results back. And by having read quite a lot, clearly not being a scientist, but thinking, well, I do know what kind of general areas are and types are, absolutely none the wiser. And I couldn't, I got the list and I thought, well, at least I should be able to spot, what I've been taking in with the VSL3. No idea. It didn't look significantly different from beginning to end. And that was, despite eating a lot of things, there were some things which looked a bit better. I felt better for eating those things. My digestion itself felt more healthy and felt things were ticking over better. But in terms of the data, I can only hope that because some of the testing was with the British Gut, which is trying to get as many samples as possible, I was achieving something for the greater good.
Yeah, I've been on a couple of rants about those companies. I'm not a fan. I think as far as the testing goes, if you're contributing to projects like the British Gut or American Gut, they are underpinned by research and people trying to understand what the microbiota is doing. But it's nice actually on the British Gut website, because it does actually, and I'm not affiliated with British Gut, I'll just point that out. It does state on their website that although you can get a snapshot of your microbes, it doesn't provide you with any interpretation. It doesn't tell you anything. They're not trying to make it as a service to, oh, if you eat this, you'll increase this. That's fine. It's just a shame more people aren't as honest as that. And I think if you've got 80, 90, 100 pounds, whatever it is, these people are charging to try and tell you what your microbiota is and how you should change it to be healthier, give it to charity. Seriously, if you've got money to spend, give it to charity.
Or buy some vegetables.
Or buy some vegetables or an allotment, yes.
I suppose maybe in 10 years, might it be interesting to look back and see that data, or will the data look in a completely different form by that time?
By that point, it would be a completely different form. At the moment, the only thing that's stopping it being in a more complete form is the cost of processing the samples and the computing power required. Because I imagine the kind of test you had done was just looking at one gene and looking at species of bacteria that you can find using that one gene. The kind of work I do is we're looking at everything that's in a fecal sample, so all the genes or all of the organisms, and trying to understand what's going on. And it's really only the cost that's keeping that from being more mainstream at the moment. When sequencing costs come down again, and they will, there's no doubt about that, they've come down massively in the last 10 years, then the amount of information that's going to be available is going to be a lot more bewildering for the average person getting results back from these things.
Talking of bewildering, but also exciting, every time I talk to somebody about this, I want to know more. So if somebody is just scratching the surface of understanding about microbes and the effect they have, what would you advise them to do, or what sources to look out for?
Well, there's the American Gut and British Gut websites are quite good places to start. There's also the Gutmicrobiotaforhealth website, it's just a really nice blog, and I think they've won quite a few awards now from the European Society of Neurogastroenterology and Motility. But they always it's updated daily or weekly with new stories. They try and put it in a context that people can understand. There's lots of videos on there. There's lots of info and graphics and things like that, so people can go and have a look at it. And it's run by people who know what they're talking about. So it's not some hack blogger. There are some very good bloggers, but unless you know the person works within the field, it's very difficult to take some of them seriously at times, especially when a lot of them seem to be linked in with selling stuff. But that's a very good resource.
So much to take away from that interview, but the overall message of balance, eating lots of fruit and vegetables, and getting some exercise is a simple one that we can all take on board. Do head for the show notes at the52dietbook.com/podcast25 to see the great links that Lesley suggested reading. And thanks for listening. That's it for today's Live Happy, Eat Dirty. For free tools and tips to help you live a gloriously imperfect way of life, go to thedirty-diet.com or find us on Facebook/The Dirty Diet. You can also tweet me at Kate Writes Books. And do have a happy and dirty day.